Welcome to class 6 physics classes. Today we are going to learn about force. In everyday life we use the word force to open a door. We either push or pull it. We throw, kick or hit a ball. Similarly, we draw a bucket of water from a well. We pull the rope. This push or pull is called force. Have you observed that a body can neither start or stop moving nor change its speed, direction, or shape by itself? When you go to school in the morning, you apply force to lift your school bag and put it on your shoulders. When you enter a shop or a bank, you find push written on the door. You push the door to get in and pull the door to come out. Football players often stop the ball traveling at a great speed. At times, you also see a player deflecting the ball cleverly. Picking, opening, sorting, clicking, twisting, hitting, lifting, flicking, pushing, and pulling are some actions that usually results in some kind of change in the motion of an object. So we conclude that body requires force to start or stop moving, change its speed, direction or shape. Therefore, force is something which changes or tends to change the state of rest or of motion of a body. It can also change the shape or size of the body or the speed or direction of motion. The state of motion of an object is described by its speed and direction of motion. When the speed of the body is zero, it is considered to be in a rest, or you can say a body is said to be at rest if it does not change its position with time with respect to its surroundings. For the force to act, the two bodies must interact with each other in some way. For example, the door of an almirah will not open on its own. Only when we apply force to pull it, it will open. So, an interaction between the objects is necessary for force to be effective. Few examples: two teams pulling the rope with enough force in a tug of war, pulling a chair to sit on it, pulling a rubber band to expand it, pulling a wheelbarrow, pushing a baby cart to move it ahead, pushing a refrigerator door to close it, are some examples of push and pull. Terms like stretch and squeeze also refer to force. If the force applied on a body results in increase in its length in the direction of applied force, then the body is said to be stretched. For example, when we stretch a rubber band, we apply force so that its length increases. If the force applied on a body results in decrease in its dimension or volume, then the body is said to be squeezed. For example, when the squeeze a toothpaste tube, we apply force so that its dimension decreases and its shape changes. So in simple terms, we define force as a pull or push acting on a body which tends to change its state of rest or motion or the direction of motion or its shape or size. Force is usually denoted by the letter F. The direction in which the force acts is called the direction of force. The direction of force is the direction in which the body is pushed or pulled. Force is expressed in various units like gram force, kilogram force, dyne, and Newton. The SI unit of force is Newton. This unit of force is named because of well-known scientist Sir Isaac Newton. Okay, now let's discuss about effects of force. Number 1, force can make a stationary objects move or stop. When a force is applied to an object at rest, it begins to move. For example, by pushing a car or pulling a trolley, the car or the trolley begins to move. Similarly, when a force is applied on a moving object, it tends to stop or slow down its motion. For example, a moving cycle can be stopped by applying brakes. Number 2. Force can change the speed of a moving object. What happens if a force is applied to an object which is already moving? If the force is applied in the direction in which the object is moving, it begins to move faster. If the force is applied in the direction opposite to the direction of the motion, the object slows down. For example, a person gives a push to the swing to make it move faster. If the person pulls the swing in the opposite direction, the swing would begin to slow down. Number 3. Force can change the direction of a moving object. Force can change the direction of a moving object. For example, a player by kicking or pushing a moving football can change its direction. Similarly, a batsman changes the direction of a moving ball by hitting it with a bat. Number 4. Force can change the shape or size of an object. Force can change the shape or size of an object. For example, the shape of dough changes on applying a force. The shape of a sponge changes on pressing. The size of a spring changes on pulling. The shape and size of an iron strip changes on hammering. The shape of a toothpaste tube changes on squeezing. You can take a ball of molding clay and make figures of different shapes and sizes by pressing it with your hands. Also, when you make a chapati, a small ball of dough is changed to a flat circular shape of a bigger size by applying a force with the help of a rolling pin. Now, if the changes after applying force are not brought about, then we can say that an equal force is acting from the opposite direction in which the first force was applied. So we can say that two forces cancel each other and a balanced force acts on the body which does not bring any changes. But on the other hand, if changes occur, a body either moves from rest, comes to rest, from motion or changes its shape or size, etc., then this shows that an unbalanced force is acting on the body. Therefore, the two objects must interact with each other in some way, either directly or indirectly. Therefore, there are two types of forces if we see the changes after applying force. Number A is contact force and number B is non-contact force or action at a distance force. Contact forces. Forces that need a physical touch on the object to act upon it are called contact forces. So, if you move a stone directly using your hands or you push it with the help of a stick, the force applied is a contact force. Contact forces can further be categorized as these: applied force, normal force, tension, frictional force. Let us know these contact forces one by one. Applied force, a force that is applied to an object by humans, animals, or other objects is called applied force. A player kicking a ball, a person lifting a suitcase, a horse pulling a cart, and an electric motor powering an electric fan are different instances of applied force acting on an object. Normal force, a force exerted by a surface to support the weight of a body in contact with it, called normal force. A force is always perpendicular to the surface. For example, when a book is kept on a table, the table exerts a normal force which acts upwards on the book to support its weight. Tension. Sometimes a force acts between two or more bodies through a connector such as a wire, string or rope. For example, take the case of a person pulling a bucket of water from a well with the help of a rope. He exerts a force along the length of the rope, opposing the force exerted by the weight of the bucket of water. Similarly, during a game of tug of war, both teams apply opposing forces along the rope by pulling it from both ends. When a connector is pulled by opposing forces from both the ends, the force that acts along the length of the connector is called tension. Muscular force. The force exerted by the muscles of our body is called muscular force. We exert muscular force while walking, running, lifting, etc. Animals exert muscular force to do work like carrying a load, plowing a field, etc. Some examples are lifting a bag, kicking a football, opening a door, pushing a chair, a horse pulling a cart, etc. Next is collision force, the contact force which comes into play when two bodies collide with each other is called collision force. For example, when two cars collide, they exert force on each other. This force is collision force. Friction. This is also a contact force. The force that opposes the relative force of two bodies is called friction. It slows down things by acting in the direction opposite to the motion of the body. Friction is a contact force as it arises due to contact between the surfaces. When you hit a ball, it gradually slows down and finally comes to rest due to friction. Similarly, a car or a scooter also comes to rest once the engine is stopped. The wear and tear caused in the moving parts of machine is also because of friction. We are able to walk properly on rough surfaces because of friction offered by the surface. It is very difficult to walk on a smooth surfaces or wet road because the smoothness or wetness reduces friction. Next is mechanical force. The force produced by a machine is called mechanical force. Actually, a machine does not exert force by itself. It works only with the help of energy supplied by external sources like electricity, petrol, diesel, etc. For example, the engine of a vehicle runs with the help of fuel and moves the vehicle. The wind exerts force to move a sailboat or a windmill. Now let's discuss about non-contact forces. When a force is applied on an object by another object without coming in contact with each other, it is said to be non-contact force. Non-contact forces act from a distance. Magnetic force, electrostatic force, and gravitational force are a few examples of non-contact forces. Magnetic force. When we bring a magnet near some iron nails or clips, the pins or clips are pulled towards the magnet. It means that the magnet has applied a force on these objects. Magnets exert pull or objects made of iron and other magnetic materials such as nickel and cobalt. The force exerted by a magnet is called a magnetic force. Let's discuss about electrostatic force. When we rub a plastic comb on our dry hair and bring it near small bits of paper, they are pulled towards the comb. This is because when a comb is rubbed on dry hair, an electric charge is produced in it. This electric charge exerts a pull on the bits of paper. The force exerted by electrostatic charge is called electrostatic force. All objects have two types of electrical charges, positive charge and negative charges. Ordinarily, these charges are equal in number, so they balance out each other and objects appear to be electrically neutral. But due to various reasons, when an object has more negative charges than positive charges, it becomes negatively charged. Similarly, an object with more positive charges than negative charges becomes positively charged. Objects that have opposite charges attract each other, while objects that have similar charges repel each other. In our example, The plastic ruler was electrically neutral before rubbing, but when it was rubbed against dry hair, some of the negative charges from the hair got transferred to the ruler. As a result of these surplus negative charges, the ruler became negatively charged. When the charged ruler was brought near the non-charged bits of paper, it attracted the opposite charges, positive charges, on the paper pieces towards it. This made the paper pieces move up and stick to the ruler. The electrical charges that build upon an object are static until they are released under the influence of other charged bodies. That is why the force applied by the static charges is called electrostatic force, and this is non-contact force. Another non-contact force is gravitational force. When we throw a ball from a height, it falls on the ground. Similarly, when we throw a ball up in the air, it goes to some height and then falls back to the ground. Why does this happen? It happens because the earth attracts all bodies towards its center. The attractive pull of the earth is an example of gravitational force or just gravity. In fact, all the bodies that possesses mass exert this force. So gravitational force can be defined as the force with which any two masses or objects pull each other. It is due to gravitational force or gravity that all objects either remain on the ground or always fall back on the ground. Gravitational force between any two bodies depends on their masses and the distance between them. A body with greater mass will exert gravitational force on a body with lesser mass. A body will exert more gravitational force on the body which is nearer to it. The gravitational force keeps us bound to the earth. The revolution of the moon and other satellites around the earth and the motion of other planets around the sun are also due to gravitational force. Unlike electrostatic and magnetic forces, gravitational force always attracts. So we have understood force and its effects. Thank you very much.